For factoring polynomials, we were going to use similar methods that we used with graphing quadratics. The first one is the difference of squares. The additional part to factoring polynomials with difference of squares means, since it's a higher degree, we could actually get more steps, and we can actually factor a little bit further. Our method for factoring the difference of squares was to look at both terms and see that if 16x to the fourth and 81 were both squared numbers, which they are. So 16x to the fourth, the square root of that is going to be 4x squared, and that is now our first term. And then we add, our pattern for difference of squares is to add and subtract the square root of our second term. Once we've done this for 16x to the fourth minus 81, you see that our result actually will end up giving us another term, 4x squared minus 9, which is a second difference of squares. We then can apply the same pattern to factor those, and we will keep 4x squared plus 9, and then break down the 4x squared minus 9 to be 2x plus 3 and a 2x minus 3. So our result are these three factors for the original 16x to the fourth minus 81, and we are finished. In the second example, we have much larger numbers, and if we're unsure if a number is a perfect square, go to your calculator, check it out. Put in square root of 625. You will see that it is a perfect square. It is 25. And the square root of 256 is a perfect square as well for 16. So since we know both of them are perfect squares, and so is any exponent to an even power, we can break this down to now be 25x to the fourth minus 16 and 25x to the fourth plus 16. Okay, order doesn't matter, the plus and minus, but hopefully you do see that as well. In here, we have another difference of squares. 25x to the fourth minus the 16 also comes out to be a second difference of two squares. So we do follow the pattern again and break this down to be 5x squared plus 4 and 5x squared minus 4. This 25x to the fourth plus 16 will not be factorable, so we leave it. And this result, you look at everything, nothing else is a difference of squares, nothing else is factorable, and we are complete. So your difference of squares with polynomials will probably end up generating another term that can be factored yet again. All right, your sum and difference of cubes. This is new. You will have to memorize these particular formulas. And if you notice, there are a couple of patterns. You see the first term for a cubed and b cubed is a plus. And when you factor it, this first term ends up being a plus as well. Same thing in the second one. I have a minus, and this is a minus. So those first terms will always have the same sign. You notice the second sign is the opposite, right? The original was a plus, that becomes a minus. The original was a minus, this is now a plus. And then the last term, this is the same. Will always be positive no matter what. Okay, so that pattern, seeing that you have the same sign, opposite, always positive, same sign, always opposite and positive as well. Okay, so our excuse me, x cubed minus 125, we'll see that those are both cubed values, so we can follow the pattern for the difference of cubes. So this will follow the pattern of a cubed minus b cubed. As an option, we can find out all of this information and write it out. If you want to then plug in, I'm going to show you both methods, writing it out and not writing it out. 125 is a cube root. Again, if you wanted to check out what it is, on your calculator, under your math menu, go down to the third one, you'll see the cube root symbol, and you can put in 125. Or, since we know rational exponents, you can put in 125 to the 1/3 power. Either way, the cube root of 125 is equal to 5. The cube root for x, which is our a, is going to be x. Cube root of 125, we just found out to be 5. A times b, we're going to multiply those two and get 5x. Squaring a, we get x squared, and squaring b, we get 25. All the 5 of those pieces will now go into our expansion. Rewriting the expansion, I'm just going to, write it out one more time to show you a couple of patterns. Okay, again, to highlight a little bit, this is minus. So when we actually expand, what did I write out? No, that's not what I want to write out. Sorry about that. Your pattern, a minus b, a squared plus ab plus b squared. Okay, so back to our pattern, the yellow sign for subtraction here will be the same subtraction there. These will be the same as the original, whether it's plus or minus. The second one, here, this plus will be the opposite of the original. And then the last one, this here is always positive. Okay, that'll help you in memorizing. Okay, so now finally our expansion for these particular values, we have x cubed minus 125. Expanding that out, a was x, minus our b value, which is 5. Our a squared value is x squared. We are going to add our ab, and then we are going to add our b squared. And this is your expansion for the difference of cubes. This is completely factored. Using the pattern for sum and difference of cubes, your final answer will always be factored. It's completely factored. You will not be able to go any further. It might be tempting to go further with the trinomial, but you cannot. It is not factorable. You are done after you use this pattern. Let's look at another one. 16x to the 5th plus 54x squared. This is now the sum of cubes, right? This is a cubed plus b cubed. Off to the side, you may want to use and write out your AB, what a equals, b equals, a times b, and of course b squared if you wanted to. But first and foremost, we should always, always, always be looking for our GCF first. Is there a GCF in this pattern? And the answer to that is yes. This GCF in this particular equation is 2x squared. So the first thing we're going to do is pull out the 2x squared out of both of these terms. So take a 2x squared out of 16, you're going to get 8x cubed. Plus, take a 2 out, 2x squared out, we're going to get a 27. Starting off, 16 and 54 were not cube numbers. So it's another way of looking at, oh, if I don't have a cube number, then let me see if I have a GCF. Okay, so now we have the sum of cubes. And I'm just going to come off to the side for those that find it helpful. And I'm going to fill in what values we actually need. A is the cube root of our 8x cubed. What is that? That becomes 2x. b is the cube root of 27, which we should hopefully know is 3. You could write down a times b is 6x, a squared is then 4x squared, and b squared, of course, is 9. Those that it's helpful for, absolutely write out all 5 of those values. Now that we have all that information, we'll come back to here. 2x squared as our GCF needs to stay outside. We're going to leave that there. And now we have a plus b. Our a is 2x, and we're adding to that 3. Right? These signs are the same as the original. Our next, we're going to take our a squared, but now we are going to subtract, right, our opposite sign. We're going to subtract our a times b, which is 6x. And then finally, always, always, always adding in the end, we are going to add our b squared, which is 9. And as I said to you before, once you expand the sum or difference of cubes, you are completely factored. Okay? GCF first, and then your expansion. Okay, this concludes difference of squares and sum and difference of cubes.